We all know water puts out fire. It's the universal extinguisher. When something's burning, we reach for water without a second thought. From kitchen mishaps to raging wildfires, water is our go-to defense against flames. But what if I told you water is made of something that can burn with incredible power? It sounds impossible, right? The very thing that stops fire is actually built from elements that, under the right conditions, can fuel some of the hottest flames known to science. Can water, the stuff that fills our oceans, actually burn? Imagine the vast blue seas suddenly ablaze. Could that ever happen, or is it just science fiction? Let's explore the explosive potential inside every drop of H2O. There's more to water than meets the eye, and its hidden energy might surprise you. We see firefighters dousing flames with water, and we use it to put out campfires. It's a tool for safety, a lifesaver in emergencies, and a symbol of calm in the face of danger. Water and fire seem like opposites. One destroys, the other protects. But what if their relationship is more complicated than we think? But science is about asking what if, and why. It's about challenging what we think we know and digging deeper into the mysteries of the world around us. Today, we'll challenge what we know about water. We'll look beyond the surface and question the ordinary, searching for the extraordinary hidden within. Water is made of ingredients, elements, with their own unique properties. Hydrogen and oxygen, when separated, behave in ways that might surprise you. What if one of those is super flammable? Hydrogen, for example, is so explosive it's used to fuel rockets and power cutting-edge technology. Could we take water apart and get that fiery ingredient back? Through science, we can split water into its elements and reveal its hidden power. This is our scientific quest, to deconstruct water and see what it's truly made of. We'll use experiments and technology to unlock its secrets. Get ready, things are about to get exciting. We'll investigate molecules, explore elements, and see how the tiniest building blocks can unleash massive energy. And we'll touch on technology that could power our future, from clean energy vehicles to sustainable fuel sources, all starting with a simple glass of water. By the end, you'll see a glass of water in a whole new way. You'll realize it's not just a drink, but a potential powerhouse of energy. You'll understand the connection between the liquid that quenches your thirst and the forces that drive some of humanity's greatest achievements. Imagine, the same element in your water bottle is also the fuel that can launch a rocket into space. That's the incredible story of water. Let's get started and uncover the science. The journey from a simple drop of water to explosive energy begins now. Water is fantastic at putting out fires, but what makes it so effective, and why do firefighters around the world rely on it as their #1 tool? Let's find out. First, water absorbs heat from the fire, cooling it down so much that the burning reaction stops. When you pour water onto something hot, it soaks up a huge amount of energy as it heats up and eventually boils. This rapid cooling is often enough to halt the chemical reactions that keep a fire going. Second, as water boils, it turns into steam, pushing away the air and blocking oxygen from reaching the flames. This thick cloud of steam acts like a blanket, smothering the fire and making it impossible for the flames to breathe. Fire needs 3 things to survive: heat, fuel, and oxygen. This is called the fire triangle. Remove any one of these, and the fire collapses. Water removes heat and blocks oxygen, delivering a 1-2 punch that's incredibly hard for any fire to withstand. That's why it's so effective in emergencies. But there's more to water's power than just cooling and smothering. Water is so stable because it's already the result of a chemical reaction. Hydrogen and oxygen have already combined and released energy. This means water is at a low-energy stable state. That's why water doesn't want to react further. It's not looking to burn or explode. It's already done all the reacting it can do. It's like a spring that's already been sprung. All its energy has been released, so it just sits there, calm and stable. This stability lets water exist as a liquid, solid, and gas all over our planet without catching fire. From icy glaciers to steamy geysers, water is everywhere, quietly doing its job. So our experience is right, water doesn't burn, it stops fire. It's the ultimate firefighter, always ready to leap into action. But to truly understand why, we need to zoom into the molecular level and see what water is made of. The answer is hidden in its tiniest parts. The secret to our burning question lies in its ingredients: hydrogen and oxygen, 2 elements that are explosive on their own, but together form something completely different. Water is the enemy of fire, but its story isn't over yet. There's a fascinating world inside every drop, waiting to be explored. Let's look closer at what's inside every drop. The molecules themselves hold the key to water's firefighting superpowers. The answer is more surprising than you think. Let's dive in and discover the science behind water's incredible ability to stop fire in its tracks. Water is a molecule called H2O, 2 hydrogen atoms and 1 oxygen atom. Oxygen is a key supporter of fire. It doesn't burn itself, but it helps other things burn. Without oxygen, most fires would go out instantly. Hydrogen, on the other hand, is the most common element in the universe, and it's extremely flammable. Hydrogen is a powerful fuel, which is why it's so interesting to scientists. Inside every water molecule we have a fire supporter, oxygen, and an explosive fuel, hydrogen, locked together. When bonded as H2O, they're stable and safe. But what if we could break them apart? If we separate hydrogen from oxygen, we get 2 gases with very different properties than water. This is where the science gets really cool. Water's ingredients are more exciting than they seem. Let's see what happens when we set hydrogen free. The results are explosive, literally. Hydrogen gas is highly flammable. All it needs is heat and oxygen to burn with a nearly invisible pale blue flame. Hydrogen atoms want to be stable, and when they combine with oxygen, they form water, releasing a lot of energy as heat and light. That's why burning hydrogen is so powerful. The Hindenburg disaster in 1937 showed the world just how dangerous hydrogen can be when it ignites. While hydrogen in water is safe, pure hydrogen is a powerful fuel waiting to react. Burning hydrogen is the reverse of splitting water. Hydrogen and oxygen combine, forming water and releasing energy. The only product? Pure water. This is a crucial clue for clean energy. Hydrogen's fiery secret is hidden in every drop of water. Unlocking it could change our world. Let's see how we can get hydrogen out of water. How do we get hydrogen out of water? The answer: electrolysis. Electrolysis uses electricity to split water into hydrogen and oxygen. You need water, 2 electrodes, and a battery. Connect the electrodes to the battery and place them in water. Electricity flows, breaking the bonds between hydrogen and oxygen. Bubbles form, hydrogen at the negative electrode, oxygen at the positive. You'll see twice as many hydrogen bubbles as oxygen, matching water's formula H2O. This process lets us turn stable water into a powerful fuel. We're reversing the reaction that formed water, storing energy in hydrogen gas. The challenge? Electrolysis needs a lot of electricity. For clean hydrogen, that electricity should come from renewable sources like solar or wind. Electrolysis is the key to unlocking hydrogen's energy. Now what can we do with all that hydrogen? Once we have hydrogen, its energy potential is huge. Rockets like the space shuttle use liquid hydrogen and oxygen for fuel, producing only water vapor as exhaust. On Earth, hydrogen powers fuel cell. Electric vehicles, cars, buses, and trucks that emit only water. Fuel cells combine hydrogen and oxygen to make electricity, powering electric motors. Hydrogen cars can be refueled quickly, just like gasoline cars, but with 0 emissions. Hydrogen can also generate electricity for homes and businesses, or provide high heat for industry. It's a way to store renewable energy and use it whenever we need it. Hydrogen is versatile, fuel for rockets, cars, and power plants. It's a key player in the future of clean energy. Imagine a world where the only exhaust is water. That's the promise of hydrogen. Why is hydrogen so exciting? Because when it's used as fuel, the main byproduct is water. Burning fossil fuels releases harmful CO2, but hydrogen offers a cleaner alternative. A world powered by hydrogen would have cleaner air and healthier cities. Scientists are working to make green hydrogen, produced with renewable energy, affordable and accessible. Challenges remain: making hydrogen cheaply, building infrastructure, and developing better fuel cells. But governments and companies are investing billions in hydrogen research. Hydrogen can do what batteries can't: power heavy trucks, ships, and planes over long distances. It can store energy from summer sun to use in winter. Hydrogen isn't the only solution, but it's a crucial piece of the clean energy puzzle. The future could be powered by the most abundant element in the universe. With innovation, hydrogen can help us fight climate change. The journey is just beginning. Hydrogen's potential is too great to ignore. Time for some mind-blowing facts. Hydrogen is the lightest element, so light, it escapes Earth's gravity and floats into space. Most of Earth's hydrogen is locked in water and compounds. Burning hydrogen creates water. Space shuttle engines made enough water vapor during launch to fill an Olympic pool in minutes. The hydrogen in your drinking water was created during the Big Bang, over 13 billion years ago. every sip connects you to the beginning of the universe. If you mix hydrogen and oxygen gases and add a spark, they recombine with a loud bang, showing the energy hidden in water's ingredients. Water is safe, but its elements are full of explosive potential. We've traveled from the warmth of campfires to the roaring engines of rockets, exploring the fascinating relationship between water and fire. Now, it's time for the big question. Can water actually burn? Let's break it down and reveal the science behind this everyday mystery. The simple answer is no, water can't catch fire. It's already the end product of combustion, a stable and low-energy substance. That's why we use it to put out fires, not start them. Water is like the finish line in a race. It's already crossed, with nowhere else to go. But here's the twist. Inside every drop of water is hydrogen, an element that burns with incredible power and intensity. Hydrogen is one of the most energetic fuels known to science, and it's locked away inside the water molecule. Water is a compound, two hydrogen atoms tightly bonded to one oxygen atom. This bond is what makes water so stable and so difficult to ignite. But with enough energy, we can split water apart through a process called electrolysis, freeing the hydrogen gas trapped within. This process is like unlocking a hidden store of energy. So, while water itself doesn't burn, it holds the potential for fire within its very structure. It's a paradox. Water is both the extinguisher and the secret keeper of fuel. By understanding the chemistry of H2O, we can unlock a clean, powerful fuel source for the future. Hydrogen fuel cells are already powering cars, buses, and even entire buildings. We can turn abundant water into energy using renewable sources like solar and wind, and the only byproduct is pure water, ready to start the cycle all over again. It's a beautiful, sustainable loop. Water is both our firefighter and, with a little science, a secret fuel source waiting to be tapped. It's a symbol of safety, yet it quietly holds the energy of the stars, reminding us of the hidden power in the world around us. So next time you see a puddle on the street, remember, it won't catch fire, but with the right technology and knowledge, it could help power our future in ways we're only beginning to imagine. The story of water and fire is a perfect example of how science reveals the wonders hidden in plain sight, turning ordinary things into extraordinary possibilities. Thanks for joining this journey. Keep asking questions, keep exploring, and never stop being curious about the world around you.